Hi mathematicians, we're still talking about rational expressions, and this time we are going to solve the denominator equaling 0 issue by using conjugates. So let's go ahead and look at this problem. The limit as x approaches 1 of the square root of x minus 1 over x minus 1. And so clearly, if we plug 1 in, we'll get 0 in the denominator, and that's a problem. If we go ahead and look, I can't factor the numerator in any way that allows me to cancel out this denominator. That's what our goal is. We want to cancel out this denominator. So what we're going to try, another thing to try, there's no guarantee that anything's going to work, is we're going to multiply the top and the bottom by this square root of x plus 1. And when we do that, on the top, let's go ahead and FOIL the top. We get square root of x squared plus square root of x minus square root of x minus 1. Right? Square root of x times square root of x is square root of x squared. Square root of x times 1, negative 1 times square root of x, and negative 1 times positive 1. All right. And I'm going to leave the bottom as is because the whole goal here was to factor out this bottom, so hopefully I'm gonna cancel one of these factors. And so on the top here, what do we end up with? Well, the square root of x squared is just x, and then square root of x minus square root of x is going to be 0 minus 1, so we get x minus 1 over x minus 1 times square root of x plus 1. And so what do we get here? Actually, I'll just move it down here. All right, and so you can just pretend this is multiplied by 1, right? And so we get, that cancels with that, and you get 1 over square root of x plus 1. You plug in 1 here, you get 1 over square root of 1 plus 1. You get 1/2. All right, and so we took a problem that we couldn't do because of the denominator equaling 0, and we multiplied it by the conjugate of this numerator, and it worked out. It might not always work out, okay, but it is one method of finding the limit for some of these rational expressions. So let's go ahead and look at one more that you're going to look at, and I don't know, it might make you a little nervous, but this is going to be number 40 from your book. And this isn't exactly multiplying by a conjugate, but just manipulating algebraically. Okay, and so clearly as we look at this, you see if I plug this in, the 0 in, I'm going to put manipulating. I don't think I can spell algebraically, something like that. Okay, so I'm going to manipulate this algebraically, hopefully, so that I don't have this h equaling 0 being the only thing in the denominator here. So let's go ahead, and what happens if I multiply this by 5 plus h times 5? Why would I do such a thing? Okay, so let's see what we end up with here. So if I'm going to multiply, I have to multiply, obviously, this by the top and the bottom. And so you get 5 plus h times 5 over 5 plus h minus 5 plus h times 5 over 5, right? Because I would have had to multiply this by this one and multiply it by this term here. And then this is all over h times 5 plus h times 5. Okay, let's see if anything good happens from all this. And so this is going to cancel with this. This cancels with this. And we get 5 minus 5 minus h. Where did I get this? I'm distributing this negative. Okay? And then on the bottom here, I'm going to go ahead and distribute all of this in. Okay, so first I'm going to get 5h plus h squared times 5. Right, multiply this in, and then I'll get negative h, 5 minus h on top. On the bottom I get 25 h plus 5h squared. Ooh. All right, so some of you might say, hey, but we still have a 0 on the bottom, but we can factor out this h, right? So here, let me make some equal here. And so let's do negative h, right? So negative 1 came out. We have the same thing. I haven't changed anything. I just changed the way I'm expressing this negative h. And so I'm expressing it as negative 1 times h here. And then on the bottom, I'm going to do 25 times h like this, plus 5 times h times h. I can do this because you can find an h in all of these terms, right? And so I'm left with negative 1 over 25 plus 5h. And so the limit as h goes to 0, negative 1 over 25 plus 5h equals negative 1 over 25. Okay, and so this is just another example that we're trying to find the limit of a rational expression, and so we're manipulating it algebraically in order to find a solution. Okay, and so here I was like, let's see what happens if I get rid of these fractions. So I multiplied by 5 plus h times 5. When I did that, I got 5 plus h times 5 over 5 plus h minus 5 plus h times 5 over 5. That allowed me to cancel, and you ended up with just negative h on the top, which is a lot cleaner to deal with also. On the bottom, we ended up with 25h squared, or 25h plus 5h squared. We factored out an h out of everything. Resulted in negative 1 over 25 plus 5h. Now I throw in a 0 and I get an answer.